Okay, this is a REI 4B Algebra Reasoning with Equations and Inequalities Standard 4 Subpart B Video 1. We're going to be using square roots to solve quadratic equations today. Okay, in your journals, I'd like you to write these words down and define them. Please pause the video here, copy down these concepts that we have. It says solving x squared equaling d by taking the square root. So we have three different situations here that could occur when we are using solving by square roots. Okay, it says solve the equation. I have put a number of examples on here that you might come across, and I didn't put in the directions that we are solving using square roots, but obviously that's the topic of the day. So we're going to solve for x as we always do. We're going to be using the inverse operations. So on the first problem here, we have a coefficient of 2 touching our variable, and we have the equal sign. So on both sides, we are going to be dividing by 2. So we're left with x squared equaling 8 divided by 2 is 4. And the inverse operation of squaring a variable is taking the square root. So if we were now to take the square root of x squared, we would do the same thing to the other side. Whatever you do to one side, you do to the other. So we'll take the square root of 4. And the square root of x squared is x. And the square root of 4, that's a perfect square. So we're going to have positive 2 and a second root of negative 2. Why is that? Well, positive 2 multiplied by positive 2 is equal to that root or that number of 4. And then the negative 2 times negative 2 is also equal to that positive 4. So we have two roots, which means our parabola is going to hit the x-axis in two spots. It's going to hit or have an intercept at positive 2, and the parabola will also have an intercept at negative 2 on the x-axis. All right, next example. Let's solve for x squared, ultimately solving for x. All right, to undo a negative 18, we're going to add 18 to both sides. So x squared minus 18, add 18, and whatever you do to one side, you do the same thing to the other. So we take our negative 18, and we had added 18, and what are we going to get? So x squared is equal to negative 18 plus 18 is 0. Well, we know that x is going to have to be 0. Let's continue the process. Take the square root of both sides. So x is equal to just plain old 0. We don't have a positive or negative 0. So we're going to have one root of the parabola, and the parabola is going to hit x equaling 0. So it's going to skim right across there and hit the x-axis. All right, last one. Subtract 12 from both sides. So x squared is equal to negative 7. We can stop right here. We don't have any square roots equaling a negative value, so our d cannot be a negative. And in this situation, we have something called no solution. And if you want to continue the process, we have x squared equaling the square root of negative 7, and that is an irrational root, so we have no solution. And you're going to learn more about irrational roots next year when you get into Algebra 2. All right, a few more examples I thought you might come across. Some interesting situation, especially this one right here. We have a a coefficient of 4. We're still going to divide both sides by the coefficient, although you're going to notice now we have this fraction and it also happens to be improper. So we have x squared equaling 9/4. The process is still the same. We're going to take the square root of both sides. And you could break it down into two separate roots, or we could do it all at one time. And what I mean by two separate roots is we have a numerator and a denominator. So we can break this into x being equal to the square root of 9 over the square root of 4, which happens to be what? We have the square root of 9 is 3, and the square root of 4 is 2. And don't forget, we have the positive and negative roots of that. So let me make a little adjustment here. X is going to be equal to the positive and negative root of 3/2, or 3 over 2. Okay, next one. Solving for x again, we're going to add 11 to both sides. I'm just going to skip that whole showing the work part for right now, just to save some time. So 3x squared is equal to, add 11 to both sides, 7 plus 11 is 18. Now we take our coefficient, divide both sides by the coefficient of 3. So x squared is equal to 6. Now we have a number 6 here that is not going to be a perfect square. So what's going to happen here? We take the square root of both sides, and x is going to be equal to, now we haven't done much simplifying of these radicals that aren't perfect, so we take out our calculator and we take the square root of 6. And we have an approximated situation here. I believe the book wants us to round to the nearest hundredth. So we can say x is approximately, remember we're rounding, so it's not equal to, so we have approximately equal to, there are two roots, the positive and negative roots of, to the nearest hundredth would be 2 and 45/100. So we're going to have two intercepts on that x-axis at positive and negative 2 and approximately 45/100. All right, next one. Subtract 14 from both sides. We have negative x squared equaling, we take this 14 over, 17 subtracted by 14 is 3. We divide both sides by the coefficient of -1. We got to have this x squared be positive, so divide both sides by a -1, and we have x squared equaling -3. And we've already run into this situation where your d cannot be a negative. Let's continue to show the work. Square root of x squared equaling the square root of -3, and that is a no solution once again. So the parabola is not going to be intercepting the x-axis in this situation. All right, the last part, it says, let's solve a quadratic equation. Okay. Well, inverse operations are still in play here. We have a set of parentheses and a 5 touching it. Now we don't want to distribute this 5 here. What we can do is quickly divide both sides by that 5 to get rid of it. And we are left with this quantity of x minus 2 squared equaling, I believe that's 14. 70 divided by 5 is 14. And now we have learned that we can take, in order to undo this square, we could take the square root of both sides to be rid of it. So let's take the square root of the left side and the square root of the right side and see what we're left with. So we have x minus 2 equaling the square root of 14. And now the square root of 14 is not a perfect square, so we will have to leave it under the radical and continue solving for x. So how do you get x by itself? Well, we're going to have to add 2 to both sides. So x will be equal to, let's see, 2 is going to be positive when I put it on the other side. So 2 plus the square root of 14. And then don't forget, the square root of 14 is going to have 2 roots, the positive root and the negative root. So now we need another situation where x is going to also be equal to 2 minus the square root of 14. And you're going to have your calculators handy, so you'd be able to do some approximations here, some rounding to the nearest hundredth. Why don't I do that for you right now? Okay, so we have 2 plus the square root of 14, and that is, x is going to be approximately 5.74, and let's see what this is. We have negative 1.74. And that is where the parabola is going to come close to intercepting the x-axis. All right, here is just a picture of a plane grid. If I were to take all of those examples and put them on a graph, the intercepts are going to be occurring right along this x-axis. So if we were to take that last example, 5.75 and negative 1.74. Let's see, am I going to be able to fit that? 1, 2, 3, 4, 5, 6. So one of the intercepts would be approximately right here, and then negative 1 and about 3/4. All right, so then we would do what we've been doing up to this point in creating the axis of symmetry. We could get the vertex, and we determine how this parabola is going to look based on all that computation that we would do. Okay, in your journal, please define the given terms on page 2 of the flip chart. Write down a few sentences on what you've learned from this video, and if you have any questions, please bring those questions into class and we can answer them together.